Our title today is Bohr's model of the atom. Emission spectra is the radiation, so which waves of electromagnetic radiation are emitted by substances. So substances can oftentimes emit radiation. And their spectra is what wavelengths of radiation are they emitting. The sun and heated solids have a continuous, that should say continuous, spectra. And what that means, a continuous spectra, is that all the wavelengths of visible light are represented in the spectra. So the sun is giving off the entire rainbow of visible wavelengths. It's a continuous spectrum. We'll see tomorrow in class that our light bulbs in our classroom also give off continuous spectra. That is, all wavelengths of visible light are being emitted by the light bulbs in our class. Opposed to that is something called the line spectra. And that consists of emissions of visible light only at specific wavelengths. So only specific wavelengths of light are given off, and those don't come out as a full continuous spectrum, but those come out as particular lines at a wavelength, a particular wavelength. Every element has its own unique emission spectra. We can look at the emission spectra of stars millions of light years away and determine what elements are in those stars because of their emission spectra. So every element is like a fingerprint of an element. Every element has its own unique emission spectrum. So the question is why? Why do hydrogen, energized hydrogen atoms only give off specific wavelengths of visible light? Or helium, or oxygen, or nitrogen? Soon after Planck, who came up with quantum theory in 1900, and that should say Einstein, E-I-N, came up with E equals mc squared in 1905. So soon after the two of them proposed their theories, Bohr provided an explanation. Okay, so in 1913, Bohr was pondering these line spectra that energized elements give off, and using the ideas of Planck and Einstein, he came up with an idea that then revolutionized our idea of what an atom actually looks like. So this is what Bohr says. Bohr says that the single electron in a hydrogen atom could only reside in certain orbits. Each orbit had a particular energy that was associated with it, which was fixed in value or quantized. So Rutherford's atom had electrons orbiting around a nucleus So here's an electron orbit, and here's an electron orbit, and here's, this is a terrible picture, never mind. So Rutherford's atom, of course, has electrons orbiting around the nucleus. But what Bohr added to this was that the orbits are actually, this is our nucleus, the orbits are actually at different distances from the nucleus. So here's one electron orbit. This is very simplified. Here's another electron orbit. Here's another electron orbit. So it looks like a target. Looks like it's a concentric ring pattern. And what he's saying is that electrons can inhabit this orbit, or this orbit, or this orbit, but that in order to inhabit these, they have to possess a certain amount of energy. And the amount of energy that the electron possesses is fixed in value or quantized depending on where, in which of these orbits it's in. The further we get from the nucleus, the more energetic the electron has to be to inhabit that particular orbit. Okay, so that's the first part, his explanation. And so then what Bohr says is that the emission of radiation by an energized hydrogen atom is coming from the electron dropping from a high energy orbit to a lower one and giving up a quantum of energy, a photon, in the form of visible light that corresponds to the amount of energy that that electron is able to release. So, if an electron that's here that has a certain amount of energy drops down one shell level, it doesn't need as much energy as it needed to possess to stay in this orbit. So, in that drop, it emits visible light. It emits photons of visible light. So a little vocabulary. Ground state is the lowest energy state for an electron. And excited state is higher in energy than the ground state. And last but not least, the brightness of spectral lines depends on how many photons of the same wavelength are being emitted. Tomorrow we will do numerous activities in class that are going to illuminate all of these ideas that I have just put forth for you. And all of this vocabulary that you have written down hopefully will help us have a better discussion in class about things that you are observing. Okay, that's it.